So this is the data set that we downloaded from Kaggle. So this is all the individual data. However, this is just a sample of 190 objects just to run our code on, just to make sure the code is working. So going through all the code, the first thing we did was we made the team data set, and the reason was because all our questions involved team data, so we had to create a whole new data set that joined all the individuals into their separate teams. And so how we did that was we used the group by function in Python, where we pretty much just match the team ID and the match ID, and if they have those in common, then it would join the individual players together. And so all the different attributes we used was game size, and so we just found the game size. We also did the dot size function, which found the party size, so how many different players are in each team. We did the dot mean of the player distance righted and player distance walked, so this just found the average distance traveled between the team. We also did player survive time, which found the mean again, and then we did player kills dot sum, which pretty much just found the total number of kills in the team, and then we also did team placement. And so after that, we just concatenated all these data sets together into one, and then we converted that to a CSV file. The next thing we did was we did team speed. And so the reason was because we didn't want to use distance traveled, just because a player or a team that makes it farther in a match obviously will have a higher distance traveled than a team that doesn't make it that far. And so a way of counteracting that was doing speed data. And so we just did player distance walked, which is the average distance traveled for the team divided by the survive time. And so this found the speed in meters per second. And then finally, the last thing we did for data preparation was we deleted some rows. And so we deleted all rows with the speed of over 10. And the reason was because there was some with like 200 speed, and obviously that can't be true. So there must have been a glitch or something like that, or cheat codes. And so we actually did some research, and the highest you can travel is, I think, 8 meters per second. So we just discarded all speed attributes above 10. And then we also deleted all rows with speed equal to 0, just because those teams weren't actually playing. So now going on to our techniques, what we did first was we just visualized some data. So pretty much we just did a bar chart just to see team kills versus team placement. And so what that looked like was this. So as you can see, as team kills increases, the team placement drops, which is good because if you get team placement of 1, that means you finish first for the match, which is what you want. The next thing we did was we did a k-means cluster, and so this code is actually us trying to implement it, but we realized that you could use a library, and so that's what we did. And so that's our code to figure out the k-means algorithm, and what it looks like is this. And so average speed is on the x-axis, and as you can see, the centroid for the bottom one is about 1.8, and so that shows the lowest placement for specific teams, and so that's what we wanted. And then finally, we also did confidence levels. So pretty much we looped through every single row in the table, and so we found average number of kills for the team. So we just did total player kills divided by the party size, because we didn't want to compare a team of 4 to a team of 3, because obviously a team of 4 will most likely have more kills than a team of 3. So we just did average kills per player. And so we looked at kills, average kills less than 1, average kills greater than or equal to 1 and less than 3, and then kills greater than or equal to 3. So pretty much if team kills had less than 1, we looked at the average placement for that, and then the average placement for the next 2 as well. And so this found the average placement. The next was winning percentage. So we used the same 3 classifications again, and pretty much we found the winning percentage for that. And so I'll show you a picture right here. So as you can see, if a team has 3 or more kills per player, the average placement was about 12.8, which is the lowest out of the 3. And also for winning percentage, if the team has 3 or more kills per player, then their winning percentage jumps up to about 17%. And then finally, we also did another test to see if first place finish with a speed of over 1.7 but less than 2, and also the team had 3 or more kills per player. We wanted to see what the winning percentage was. and it dropped down to 10%. And we believe the reason is because of overfitting, just because we kind of classified too much and there just wasn't that much data to test it on, and that's why the number dropped. And so, as you can see, our final results show that if a team has over 3 kills per player and travels about a speed of 1.8, then they have the highest chance to win. And also, how we can use this results is tested out in the game so we can actually play and kind of keep constantly moving and try and get as many kills as possible, and that would give us the highest chance to win. Thank you.